Ba-ba-da-ba. Going live, and we're live. Okay, if you can hear me and if you can see me, put it in the chat, please. My name. Oh, that's the worst thing that's ever happened. Hold on. I had monitor mode on. That's so crazy how that happened. Okay. I had monitor mode on. I'm so good at streaming. You guys have no idea. Okay. Welcome. Howdy. Thanks for joining. And today we are going to be making some rocket parts. We're making the attachment points. Something. Hello? Hello? Where is this sound coming from? Hold on. Where is this sound coming from? Monitor off. This is insane. What is happening? How is the mic coming through here? Why? MacBook Pro speakers. Am I like monitoring through system preferences? This is so great. Yesterday's stream was pretty good. Wow, this is so. Okay. You know, audio from main camera. No, I don't think so. I can check. This didn't happen yesterday. I mean, maybe I just wasn't listening to it. Sync offset, monitor off. Oh. You know, I'll tell you what, does it sound normal now? Does it sound totally normal to you? Does anything sound off? Because I'm just gonna mute my laptop and that's probably gonna take care of it. Okay, great. Well, I don't know what the hell that was. Thanks for joining. I'm so glad that that's how we opened it. Got my little Celty boy here. I got a little black cherry. A couple of housekeeping tasks before we get started. So I squared up this stock material. I took the fly cutter, squared it up. So these are real sharp edges now. But mostly I just wanted to get nice surface finish on the bottom. And oh yeah, I got the TI-84 shirt. Shouts out, graphing calculator. Yes. So the housekeeping things, I need to get a new external battery for the GoPro. I put the G-code on the machine, and then there were like one or two other things I had to do. Oh, we have to make a new tool. Sorry, we have to change one of the drills out of the drill chuck. And after that, we can start the operation. Should be pretty smooth. I spent a decent amount of time like working on the tool paths. I also ate an entire frozen pizza before starting the stream, which has its benefits and drawbacks. One of the drawbacks is that I'm very full now. I'm gonna get a new battery. We're gonna change the drill bit in the drill chuck down there. And once we do that, we'll start milling. And until then, enjoy this RGB view of the CNC. Okay, new battery. I'm trying to change the battery in this GoPro here. Shouts out. Excellent. Okay, now the next thing that we need to do is get a new drill in the chuck. So I'm gonna pan over here. This is where it's all gonna happen. There's a different piece of stock material. 1 second. Got this. We do not need the 1/4 inch bit, which is good news because this isn't ready to be used. Do you need chuck key? So all we're doing here is I've just got the wrong drill bit in this chuck, and got to swap it out for the right one. 544. So we need a 3/8 drill, which I think should be here. Yeah, 1/2, 7/16, 3/8. Here it is. Here's a big boy. Wow, is this gonna work in our park? It should. Okay, that's great. And then we gotta measure our tool length. So 0 all the way up to 6.653. All right. Stand by. You can see what I'm doing here. So this is going to be our G code. We're going to load that and double check the tool that we need to use, which is here, tool 11, which is diameter 0.375, 118 degree taper, and it's a drill. So on the offsets, we're going to take this, what was it, tool 11, right? We'll take tool 11, just change this to 3/8 drill, which doesn't have to be perfect. Oops. 3/8. This is just so that we know what it is. Diameter 0.375, and the length, which we just measured, is 6.653. 6.6530. That's tool 11, and this lets our machine know the relative height of everything else. Tool number 1 is the other big tool that we're using, which is a 3/8 end mill. The length is 3.7975, and we can double check that here. Haven't used it in a minute. And 3.801. Yeah, so this is really close. We can update it though. 3.801. No, it is 8001, isn't it? So 01. No, it's not. Never mind. It's just 10. Either way, this is like we're counting hairs, counting width of a human hair here. And then the other tool that we're using is a spot drill, just to get the hole started for the larger drill for tool 11. Actually, I think it highlights these. If you look at the darker red, it's highlighting the tools that we have to use in the op, which is pretty cool. This is our op here today, so what we're doing is pretty sort of easy to see. We're making an upper attachment point for the center part of this camera spinner. This is going to make more sense as like time goes on, but basically it's we're making 2 of these parts. We'll probably only make 1 on stream unless it goes really fast and easy. But let's get started. Okay. Ba-ba-ba. And go back here. Okay. So, a little bit of housekeeping before we get started, which I already said. This stock goes a certain way in here. So this edge got faced off, and this edge got faced off, and then the top and bottom got faced off. But it's mostly important that this one and this one did. These are unfinished edges from the stock material, and this one got nastily cut by my chop saw. But it doesn't matter. These are the milled faces. These are the nice edges, so that when it fits in this vise here, it has a really good surface contact on like both sides. Now we need some parallels. If you were here yesterday, you know what these parallels are. I don't think there's any like super specific height we need. The more you can lock onto the material, the better. You can probably go lower than that. But you also don't want to like crush the material, because we're cutting out a decent amount of it. This is probably fine. Okay, so one more time. This is a bad edge. This is a bad edge. This is a good edge. This is a good edge. So this goes in the middle this way. Right? Bring this forward. Clamp it down. Try to get it mostly centered in the vise, but it doesn't really matter. Cool. I think it's fine. It's probably overkill. Alright, that is held clamped in there, and then the only thing we have to check here is our travels. So, imagine you have a drill bit in here that's not a fly cutter. Can you go all the way here? Yeah. Can you go all the way this way? Well, not quite. So this is why we check the travels beforehand. We're going to go up, we're going to loosen up the vise, and we will have to dial it in again, which kind of sucks, because it took a lot to do it last time. But we want to make good parts. So we're going to knock this back a couple of times. That should be plenty. And now, the part that kind of sucks more is that we have to redial it in to the dial indicator. It's not that hard to do, it's just stupid. Okay, so, I'm going to do this on the other side so you can see it better. We could do this on not the whole vise if we wanted to, but it's fine to do it on the vise. It's also not going to be super accurate if we're coming at it at an angle, but want to clear the stock material. So let's creep up on it, the x-axis. All right, there we go. So now we can move along the y-axis and see what kind of runout we have. And actually, we have so much runout here that, let's do this. Okay. This way. We go down a whole lot. This is not up. That's actually pretty good. Okay. Hey, screwed up on it a little bit more. You can see we're engaged the whole time. All right, that's good enough for me. So now we crank it down, get rid of this. Woo, nice and tight. We do not want this coming off. All right, so our work is really tight in the vise. Next thing we need to do is probe it in. Whew, how's everyone doing? Are we chilling today? Also, I'm sorry, I'm missing a whole lot of chat here. Joe Barnard is my spirit animal. YZAG says, is this the Krusty Krab? This is the Krusty Krab. Also, thank you, Rockets and Vibes. How's it going, Joey Bizzle from Joey B Rocket Reviews? It's going great. Thank you for the super chat. Hoping we can make some good parts tonight. Who else we got? We got Alex, Carlos, Wolf555, your MJK, Bloxy. We got Coop, got Kate, Awesome Avionics. Got everyone here. Joe, Everyday Astronaut, be giving. Uh-oh. What is my man Tim doing? What is up with Mr. EA here? Oh, hell yeah. Everyday Astronaut says, he says BPS Space and Joe Barnard is his favorite YouTube channel. I have to agree with him. I'm curious what everyone's favorite YouTube channel is, though. All right, let's not get a splinter. And now, let's probe off our part. So we could probe off using this vertically, but that's not really what I want to do. What I want to do is find the center of the part. And I think we're going to do it on one of these upper edges, and it should be okay. Okay, so the first one that I want to do is not going to be in the center of the side. Also, our travels look a lot better now. We have full travel range with the part. Okay. So we're going to tap off here. In our probe, we're going to find X+. We're going to set the WCS origin. Hold on. Excuse me. Okay. And we're going to find this one. And now, here we go, 3.985 divided by 2. 1.9925. Oops. 1.9925, that's what I'm looking for. 1 point. I'm going to check what's going on in the other room. I'm taking care of some cats right now, and they have an automatic feeder, and every now and then the feeder turns on, and it's like, what the hell is that? Hold on, let me just make sure no one's like robbing my house here. How are we doing in here? All right, all good. Just feeding the cats. All right, so now we need to find the forward and backward center. So we go probe Y+. And find Y-. 3.866 divided by 2, which is 1.933. Oh my gosh. 1.933. Boom, 0. Okay. So this is pretty much our center, which makes sense to me. That definitely looks like the center. And then the last 0 we have to find is the 0 vertically. But we don't do this with the probe. And the reason is that the thing that's actually taking off the top of this material is this, the 3/8 bit. So what I'd rather do is just use that 3/8 bit to get our offsets. Okay, it's close enough. Z0, up, we're all zeroed in. So now, I can sort of see where, oh, see, I used the wrong tool. I do this all the time. I used the wrong tool to set our zeros. Where did that piece of paper go? All right, and Z0, that's tool 1, and this should be right on the top. Yep. Cool. Okay. What else? 0.12, 0.6. I don't think there's anything else to do really, except mill to part. You can dial in the coolant angle here. Get it down a little bit. And we just make sure that we're getting it right in the right place. That is about right. Maybe a little bit more like that. All right, are we all ready? How are we all doing? What type of aluminum is that, says Tom Cross. Shouts out, Tom. This is 6061. The bits are all carbide, and a lot of them are from Tormach. Please can we have a camera on your TI-84 while you divide numbers by 2? I'm afraid, you know what's the best part? I've never owned the TI-84. I had the TI-74. Whatever like the not as good version was. And a bunch of my friends had the 84 and I was always jealous. Okay. Yeah, I think we're ready to go. Our work is in there. It's nice and tight. Put our work coordinate system in there. We're going to start running at half speed, which is what I usually do. Just in case I mess something up. Like I didn't check my feed rate super closely. And if you were making a ton of parts as part of a big machine shop, you'd be thinking a lot more about this stuff than I am. But my goal is to make like 1 or 2 parts usually. And you can get away with adjusting speeds in the flow that way. Usually pretty well. I wish the glass weren't so blurry though. Or the polycarbonate, whatever you want to call it. Okay. Let's see if I did all the math right. Everybody ready? Got my program. Put it in the chat. Should I send it? Someone tell me to send it. Santa Fe style with chicken. Someone's been watching my TikTok. All right, let's send it. Here we go. Feed down to 50%. Cycle start. We can go faster than that. This is speed at 80%. And those chips still look pretty small. can bring the microphone over here a little bit better. All right, speed up to 100%. Pretty easy so far. Wimpy cut. Listen, Sue Mark, not all of us can make a beautiful thin can like yours. The cuts will probably get a little bit more aggressive, and we could probably push this a little harder. Maybe we will. We can probably push this a lot harder. I just don't want to break tools, and I'm not going to buy a whole lot of time just because I'm not doing a billion parts at once. Here, I'll go up to like 130%. The cut should be a little deeper for the next one. For the next pass. We just have 2 facing passes here, and then we get into the good stuff. Why no full flood coolant? We get this question pretty much every time. Mist coolant is better for the visuals, like you can see what you're cutting better, and because I do YouTube stuff, it's like nicer if you can see what we're cutting. And then flood coolant is better if you're using the machine all the time, and it's constantly getting used, but letting flood coolant sit for a while makes it kind of gross. And so if you're using the machine intermittently like me, like before the parts that I've started milling for Meat Rocket, I had like 2 months where the machine did nothing. And that's pretty common for the type of stuff that I do, where like I'm not always making parts, if that makes sense. Or I'm not always like milling stuff. Sometimes I'm writing code, sometimes I'm 3D printing things, sometimes I'm doing flight testing. So the machine sits idle sometimes, and that's basically the reason. Is this a 3-phase machine? No, it's not. It's like just a wall outlet. It's awesome. And honestly, my house has really terrible wiring. If you have the AC on, people who've been to my house can vouch for this. If you have the AC on and you use the microwave for more than 30 seconds, you will, woo! There it is. If you use the microwave for more than 30 seconds with the AC on, you'll blow the whole house circuit. Putting the spindle speed up just a little bit. I think it seems a little happier here. Yeah, Trevor Miller is right about this too. I'm almost always doing just aluminum, so I don't need crazy cooling. Like, you can do aluminum without coolant if you're careful, and mist coolant helps a decent amount here. Just good chip clearing is kind of important. guys keep an eye on this for a second? Someone scream really loud in the chat if something goes wrong. I'm gonna go replace the battery for this. Did everyone behave? Alright, this is the start of the adaptive toolpath. We left a little lip on the edge there, which kind of sucks, but that's easy to take off with a deburring tool. Now we have a lot of adaptive work to do. I'm going to speed up the feed just a little bit. Maybe one day we'll start cutting. Hello? Oh my god. I think our adaptive is starting at the layer that we just already cut. Whoops. Alright, well, I goofed that up a little bit. I think we may just have a decent amount of cutting air to do. My feed rate is up as fast as it can go, so we'll have to just wait it out. Any day now. I love cutting air. Here we go. What an amazing adaptive toolpath. Literally incredible. got a little bit. All right, I think this is the end of the top adaptive, so we should be plunging again soon. Here we go. There it is. Much better. There's quite a lot of cutting like this to go, so it may be a hot minute. How's everyone doing? Sorry for the random question, but was wondering if you could tell us a bit about your 3D printer. I just got into it recently and would like to know what you do. So my 3D printer used to be a Prusa i3 Mark II, and this fall I got a Prusa i3 Mark III. Big change. No, the Mark II has been great, both the Mark II and the Mark III. The Prusa i3 machines are amazing. They are expensive. It's like a totally worthwhile investment though if you're going to print a lot of stuff. If you're not going to print a ton of things, or you just need it to like do some smaller projects, you don't probably need to spend the money to get a Prusa. The big sell with the Prusa machines is that I have not needed to do any maintenance on them ever. The only reason I bought the i3 is because I was printing a lot of parts at the same time. And mostly the i2, like, I had my first problem with it. I had like some hot end jam or something like that, or the Mark II, I had some hot end jam, and I got so terrified of the idea that I might lose my printer in the middle of like a build cycle or something like that. The printer might die, and then I would have to wait like 2 weeks to get a new printer shipped to me. So the i3, or the old printer was sort of on its last legs, and I got the new one. Oh, also, what was the question? It was, I'd really like to know what you do. Yeah, I use those machines, and then apart from that, I mean, they're mostly just printing like any parts I make in CAD. They make great machines, and you can pretty much design whatever you want, and they'll print it. All right. Have you ever thought of making a jetpack with solid rocket motors? You know, I have not thought of that. Or, why don't I put it this way? I have thought of that, and then I've thought better. A jetpack with SRBs seems like a really good way to have a deep, visceral understanding of what it means to have a rocket motor blow up, and maybe not in a way that you want. How much was the Tormach? So I worked with Tormach. I did not actually pay for this machine because of how wonderful this company is, but mostly it was a sponsorship. So I produced a video for them on their channel. I did some promotion for them, and they get promoted on the BPS channel pretty constantly as like part of a contract. And so they sent me this machine so that I could make parts and then promote their brand. This machine though, the cheapest version of this is $7,000 something, I think. You can check on their website. And then as you start to add the enclosure and fancier parts and like a tool changer, I don't have a tool changer, but like the, not the automatic, like the air compressor release tool thing, it gets more expensive. All right. What are the body tubes? What body tubes was Sprint made out of? Sprint is made out of 66 millimeter body tubes. It's the like BT80 tube that Apogee sells. What is the spindle speed? What spindle speed is your machine capable of, Joe? Sumark, my machine can go to 10,000, and right now it's at 4,600. Model Starship stuff, please. It's coming at some point. Any thoughts on getting into resin printing? Maybe. I have a whole lot of ways to make parts right now, and resin printing doesn't super align with the direction that the size of the rockets are going. If that makes sense. Getting better at CNCing, I think, is a more worthwhile endeavor for me right now. Okay. Let's see. Just replace the nozzle. Okay, I think this is in reference to the printer. You can just replace the nozzle if you have a hot end jam. That's true, except for sometimes you can't. So the idea was like, the hot end jam is not a hard thing to fix. Anyone who's 3D printed has usually fixed some type of thing like that, where you have a big backup of filament. But the problem was, there's a bunch of wiring on the, like, in the internal cable that, like, connects to the hot end, and, like, some of that is wearing down. Like, I can see frayed wires in a couple of different places. And so it just felt like testing fate to keep using that and nothing else. Opinions on carbonated milk. Oh my god. Alright. Is the RGB a supported add-on? Should it be? It's not a supported add-on. Tormach was really cool about me adding these LEDs. I thought they would be like, no, that's not our machine. You need to take them out. But I quite like them. They make everything look better. You set it to all sorts of different colors, right? Got like super different colors you can go to. You got all these different modes. It's awesome. But it's not an official add-on. Okay. Joey B at HNS 23? Maybe. We'll see. I don't know where it is or when it is. Be cautious. Nice. Okay, I'm a little behind on chat here. You should crank that spindle speed for aluminum 12 to 15K when I can. All right, I can crank it. You want to crank it and go to a higher feed rate? We're doing a lot of really thin passes now. This toolpath is not at all optimized. You know what? Okay. We are going to go back into Fusion and re-optimize this toolpath because I'm doing way too many fine step-down things that I don't need to do because I clean them up later with a radial pass. So I'm going to go clean this up in Fusion 360, repost the G-code, and then we're going to run this up again, but better. Okay, BRB. back. We back. It's happening. It's hip. We're regenerating the G code, or I guess we already did. We'll remove the facing operation so we can jump in a little bit easier. And we should have fewer step downs. Should be a faster operation. We're going to take it from the top. And that means that we're going to mill air for a little bit. I also fixed that we should start at the model top. We also have a steeper step down. Oh, nice. We're cutting more. We're cutting more per, like our roughing step down is a deeper depth, and our finishing step down is a much deeper depth too. So our finishes on this adaptive path are a lot more rough because we're going to come in on the part that's like, there's some diagonal parts in here, and those get like radial milled out. So they'll end up looking smooth either way. It's just inefficient for us to do a lot of finishing at the beginning of the operation. So we're gonna cut air for a hot minute here. Okay, I've missed a decent amount. I want to put my finger in that machine. Do you? Are you sure? You able to zoom in more on the part? Yeah, sure. We can get rid of that on-screen display too. That's fine. Let's do it this way, where you're looking down at it a little bit more. That's pretty good. Not so bad. Okay, send it. Simplify 3D. Oh, Simplified 3D is great. I like it. I don't use it anymore. I use Prusa Slicer now, but I used it for a long time. Cutting air again. Wow, I'm really behind, sorry. Is Sprint taller than Scout? I don't think so. We're about the same height. One's probably taller, but I don't know which one. The meat rocket is something that cooks steak, Trevor. You pretty much got it. I think you got the idea. Excuse me. This would be test hardware for the space shot. Sort of. It's all tests for the space shot. We don't start making space shot parts until this winter. So we're going to start off the motor that we're using for the space shot. It's two of them. It's baby Q. It's like low end of the Q range. So it's a 6-inch motor. It's about 8, maybe 8.5 feet long. And I've got like the basic design in my head. I don't have any CAD for it yet, but it looks okay in like Burn Sim. And we have Aerotech ready to make the grains whenever it's time to actually send it. But we're gonna static fire hopefully this winter, and then we're really like on the road to space shot. I was watching the Send It video and was wondering what the connectors you used on the top of the avionics bulkhead. It looks like you had some kind of sealant on them. So the sealant is just epoxy, and that's just to hold it on there, Brandon. But the connectors are called Wago connectors, and they're awesome. I really like them a lot. Just want to make sure we're not crashing the machine here. I really like the current close-up view of the part. Keep it there. Awesome. Good to know. What glasses are those? These are just regular safety glasses. 3M. Stepper motor songs. Meat Rocket was not inspired by XKCD. No. All right, hold on. Time to cut some metal. Yeah, there it is. That's a good sound. And those are good sized chips. Win in-house made BPS motors. I don't think I'll ever make any like in-house stuff apart from a solid motor is a lot of different things, and part of it is mixing and casting the propellant, part of it's making the nozzle and the closures and the case, and I'm doing the second part of that. What are you using to simulate the space shot? Right now, OpenRocket and RAS Aero. I'd like to get a couple more results from like different sims, but between the OpenRocket and RAS Aero, and mostly RAS Aero, you get a good sense of like, are you going to make it or not? So with those two Q motors, we're shooting for 135 kilometers, and the good news about that is that like shooting for 135 gives you a lot of margin to mess up your simulation and your aerodynamics, and having like button head screws or extra drag that you don't think about, so that we could still probably get above 100 even if things are really bad. And the rocket has to stay together. Would you be allowed to make your own rocket motors? Yeah, there's no rules against it. You can make them. There's definitely rules about, you know, how you can fly those motors, but doing for the nozzles for the Q motors, big phenolic carrier and graphite throat. That's my plan, Andrew. Again, I don't have CAD yet, so like take it all with a grain of salt. My plan though is that it's the phenolic carrier and graphite throat. What is the cost for your space shot motor? Each motor is over $10,000 just in propellant and casting. The case is about $1,000 of raw aluminum, but that doesn't account for the milling of the case, and there's 2 cases per rocket. So like the space shot's easily like $30,000 or something like that. And this is a ton of money. This is not money that I can like throw around. So a lot of this, like when we do the actual space shot, it might have to get crowdfunded or something like that. But it is not cheap. Are the disco lights of the machine custom? Yes, they are. I mean, they're just RGB LEDs from like Amazon. If I go to the GoPro view, you can sort of see how they're like laid out. Oh, I guess not. Hold on. All right, going well so far. Don't go blowing up custom PVC motors. Don't make motors with PVC. Please do not do that. PVC is not a good case material. On-shape or Fusion 360? I'm in a little bit of both right now, and I'm trying to move all the way back to on-shape. Autodesk is moving in a direction that I don't love. You have to concern yourself with ECCN, ITAR control stuff when putting together videos. Not right now, Sean. The stuff that I don't show is like a decent amount of the code thing, but I think the code is even less about showing it and more about like giving it out. And even that is like, I don't know. My code is not crazy advanced. We're not simulating like orbital trajectories or suborbital trajectories or things like that, I don't think about it that hard. Any new merch coming? Nothing on the books right now. Nothing on the books right now. Yeah, Onshape does have cam in the works too, which is cool. I'm not a fan of the new... I'm a Fusion 360 kind of guy, but Onshape is really good. Yeah, Onshape was a lot newer, like a few years ago. I used to use them a lot more heavily, like 3 or 4 years ago. And then I switched over to Fusion for a little bit. And it's sort of like I made the wrong switch. I should have just stuck it out with Onshape. Fusion has a lot of great features, and like the cam in Fusion is great and really well established. But I don't know. Autodesk is just like, I'm doing some FEA or finite element analysis to like see how strong my fins need to be, and I'm not doing a whole lot of it or anything that's crazy high fidelity. But for the FEA that I'm doing, it costs you credits to simulate. You have to like buy credits to simulate on the cloud with Fusion 360. You used to be able to just like let your computer run for a really long time if you have a high intensity computation type thing, and now they force you, and you could like optionally run it on the cloud, but now they force you to run it on the cloud and pay for it. So it's the worst of both worlds. Sebastian says, do you have any videos going over how you design the flight controller PCBs and what coding language they are in? There's a series of videos that I talk about the like blip and blop computers, so it's the landing model rocket series, and I sort of show the design of those computers in EagleCAD. And then for the coding stuff, I don't have any like big coding videos really. The end of Scout E, the Scout E engineering cut, and I think the end of the Scout F engineering cut both have some sections on code. About making motors, do you have thoughts on the Alice Ice engine? I don't know what that is, I'm sorry. Do I get on well with my neighbors between the workshop and random rocket fires in the backyard? So I'm not going to say that I've never fired rockets in the backyard, or at least rocket motors, but I don't do any of the loud ones. The rocket motors I fire back there are like nothing bigger than 1 or 2 of those F-15 motors. And then for the mill's actually not that loud. Like, I'm kind of yelling, but this is about as loud as the mill gets. Honestly, the desktop CNC that I had, the Carbide 3D Nomad, was louder just because of all of the chatter. What are the pulsing colors on the bottom left coming from? They're coming from all the RGB LEDs. Alright, we're about halfway down through this adaptive path. We can probably go faster. what do you do with all of the aluminum chips? Good question. So far, I've got these two. These are all filled with aluminum chips. So, the plan is that at some point, we're going to need to fundraise for BPS for this space shot. And when we need to do that, I would like to produce some art, maybe some coasters, maybe some who knows what, but some type of art with these aluminum chips in it. So you can be like, you can buy something that has these chips that we're making rocket parts in it. So I'm saving them for something, but I don't know what that something is. Any opinion on FreeCAD? The one time I used FreeCAD for like the first year of BPS, and I found it very hard to use. That said, I think I would have found any software hard to use because I didn't know how to use CAD. All right, we're getting the ultra close-up view now. Making rocket motors from CNC aluminum chips would be pretty metal. That would be cool. What advantage does the adaptive path have over a normal G-code? Does this have to do with the conversational functionality? No, so that's a good question. The idea with adaptive, as you see the tool, not right now, it's doing like finishing stuff, but as you see the tool move through the metal, especially when it's taking larger cuts, you'll see it's like trying to stay the same amount engaged in all of the metal. So the adaptive toolpath is basically like, you don't really care what direction you're going. You do care if you're climb or conventional milling, but it's mostly like keeping your tool engagement the same over the course of the whole cut. So this is a plunge right here, so this is not really part of the adaptive, this is just entering. And then once we get to our depth, now we're trying to do the adaptive milling, where we're trying to keep the same amount of tool engagement throughout the cut. So we're not plunging all the way in the material, and it's supposed to help increase your material life, or sorry, your tool life. If you could put something in orbit that you own, what would it be? I don't know. I don't know that I have a really, like, I would put some type of maybe special pin or, like some little desk toy that I could keep on my desk and be like, look, this has been to space. That would be nice. How many KSP mods do I have? None, or almost none. I don't play KSP that much, and when I do, it's not super heavily modded. Melt the chips into BPS coins. That's a cool idea. What's the worst time you messed up cutting something with the CNC? Excuse me. I mean, the worst time with the CNC was less about the CNC and more about what I had to do after. So, like, the worst time with the CNC was, I think, when I made the landing leg mount for Scout F. The first time I tried to make it, I drilled all of the holes, I did all of the operations, and I started tapping all of the holes. And when I was tapping one of the really tiny M2 holes, an M2 tap got stuck inside the hole, and the whole part was ruined. It's a small enough tap that it was really hard to like actually get it out of the part. And so I just had to remake the whole part. It sucked. We can increase our coolant a little bit. There we go, just a little bit. make a BPS logo and give it to patrons. That's a good idea too. On more complex cuts, does the adaptive keep the tool's Z-axis engagement the same as well? Okay, yeah, good question. So I'm running a 3D adaptive strategy here, which is, or a 3D adaptive recipe, whatever you want to call it. And the way that it's working is that there's a rough step down and a fine step down within that rough step down. So we're in the rough part of the step down right now, which means that we're going throughout the part and we're taking off, I think it's like 0.18 inches of like step down, and then milling out whatever happens at that 0.18 inches. And then at the very end of the cut, you'll see we go around a few times at a slightly elevated height, and we finish off some of these like diagonal strut things that are on the side of this part. There should be 6 of them circumferentially. There's lots of different ways that you can mill parts though. This is just one of them. Big now. Walk away for 2 seconds. Yeah, this is a big part. It's a 4-inch diameter part, or almost 4. Can you make the CNC do the tapping? My CNC cannot do tapping, or at least it can't do rigid tapping, which is a thing where you control the spindle speed tight enough that you turn and plunge at the correct rate to actually tap a hole. And honestly, it's not super useful unless you're doing a ton of parts that all have tapping in the same direction, or you're constantly working on a 4th axis or a 5th axis. So I don't mind just tapping by hand. Are you going to play KSP 2? Of course I am. It's going to be fun. If money wasn't an object, what would you build or fly? I would do the space shots sooner. A lot of like meat rocket, and we're gonna do a single stage version of the space shot, and like these rockets are good for building experience, but a big part of doing some of the like bigger projects that I'm doing in the next year is not necessarily for experience. It's for raising money and like doing a couple of flashy things. Like Starship is a really good example of this. I want to do a Starship anyway. But it's an added benefit that like the videos will probably perform really well because Starship's very popular, and that will help fund space shot stuff. How are you doing tonight, Joe? I'm doing pretty well. My throat is a little bit sore. I had a few days where I thought I had a cold and then it sort of went away, and now it came back. So I don't know what's going on. But yeah, I'm hoping we can make some good parts tonight. Have you tested your 4th axis yet? I have not. It's totally possible that it could not work at all. I haven't tested it yet, but it's definitely going to get tested soon. Alright, let's clear some of these chips. Camera is dying. Alright, stand by on this view. My camera is dying, so I have to replace the battery for this one. All right, how are we doing in here? Still looking good. Z-cam is not on yet. There we go. If you could, would you send a rocket to the moon or send out a deep space probe? Definitely to the moon. No disrespect to deep space, but the moon is where it's at. How much do you expect to get out of your space shot rocket? Oh, how much use? Do I have a planned number of flights? Oh, it's all single flight. All of this stuff is single use. There's a possibility we reuse like 1 or 2 pieces of the rocket, and like when we do the first flight, or like when I static fire at FAR, that case might become a new airframe. But for the most part, it's all single use. I'm gonna do 1 space shot, and if it works, that's awesome. The ROI, like the return on investment on doing a second space shot, is really low unless we sign a customer to go to space. And even then, it's like reliability is probably pretty low on it. So it's kind of like the Scout landing. Like, it's not really worth it for me to keep trying to land Scout as it currently stands. It's more useful to try a new project and like move on. How is it living in California near the HPR community? It's amazing. There are so many people out here who do rockets, and it makes it really exciting to do that with them. Wish I could say that in a better way. Hey, I'm back. One more question about the run cams. Any idea on how much they were? You should look on the internet, because I am not Google. Respectfully. Joe, I hope this isn't a weird question. Has COVID caught on to you, or some people you know before? Yeah, I know a ton of people who have COVID. I think most people do, or who had COVID. So I think I never got it. Hold on. I think I never got COVID, but I also kind of think I did get it. So I never was symptomatic of COVID, and anytime I was symptomatic, like this little cold and scratchy throat right now that I've had, I've tested a couple of times, and it's always coming back negative. So I don't think I have COVID. But a couple of people who were pretty close to me had it over the summer, and every time I tested then, I didn't test positive. But then I got the booster shot. I got a booster like 2 or 3 weeks ago. 3 weeks ago now. And I felt almost nothing. So like the first time I got the booster was in March, and it knocked me on my ass. I was fully out for like 3 days, just in bed. And so I expected the same thing with the booster 3 weeks ago, and I felt almost nothing. I felt a little tired. So I'm wondering if I like had COVID, was asymptomatic. Anyway, I don't think it's a weird question. Okay. Ricardo says, Joe, what budget but good DSLR would you recommend? Sorry for being a bit off topic. No, dude, we're all off topic. It's the Joe Barnard channel. It's so boring to just stand here and watch the CNC, so I'm happy to chat about whatever. So DSLRs, the one that I have now is the Sony a7 III. Let me look up the price of this, because this is like one of their cheaper ones, I think. Sony a7 III. Okay, so right now you can get it for $1,600, and it looks like you could probably, or I guess $1,700, you could probably get it for less used. But the reason that that's so much money is this. Check this out. So behind the lens is the sensor, right? and the sensor is what's called full frame. Oh look, there's me. I'm in the sensor. The sensor is full frame, which means it's quite big, and it gives you really pretty shots. And you don't need a full frame sensor. So what I would do is they've got like, it's like the A6500, I think. There's a couple other cameras that will let you change the lens. Oh, the A6500 is a decent amount of money. I would get a Sony, is my first part of the answer. If you want to do video, I would get a Sony. If you want to do photos, I would get a Canon or a Nikon. But Sony is definitely like killing it with videos. Yeah, Ricardo says drogue only. That's the other reason. The space shot might be drogue only, which means that when it lands, it might get bent. Space shot is a sub-minimum diameter. The case is the airframe for the space shot. That is correct. If you had the opportunity to sign a customer, would you? I would do it for like a ton of money. If it were like a really good price, I would do it. But because I have a job that like employs me now, and I don't have to have a customer like that, I think if a customer was like, I'll give you $10,000 to fly my thing to space, and the rocket costs 30, I'm not going to do it, right? I don't know. Why don't we see if I can actually get it to go to space first? It's a pretty ambitious project, and I like talking about it as if it's like really easy and possible to do. But it's very possible that I do 2 or 3 space shot attempts, none of them work, and then I'm like, I can't afford to do more. Alright, when are you going to get more meat rocket info? I think I'll get some more meat rocket info out when we do the video on the camera spinner. So that's what I'm making right now. And this thing is going to fly on Send It, ideally, fingers crossed. It'll fly on Send It on November 12th at, maybe it's November 13th? It's the Saturday. That's Saturday of Rockstock. So if you're in the LA or California area, you can come out and see if this works in person. And then so when I make the video on this camera spinner, you should get some more info on Meat Rocket. I'd like to place my order for tacos. What's the largest cost associated with the space shot compared to a normal rocket? Well, the motor is definitely a big one. What's going on outside? Hold on. I don't know. Yeah, I think the motor is probably the biggest one. I'm paying Aerotech to cast the motor because... So it's really easy to blow up a solid motor, and it's really easy to do it in a bunch of different ways. And one of the most dangerous parts of making a solid motor is mixing the propellant. Like once the propellant is mixed and cast, it's not hard to not light the motor. Like you have to be pretty intentional about lighting that motor for it to become a problem. And even still, once that propellant is cast, it's not an explosive. Like, it doesn't become explosive until you contain the explosion, and then it's a problem. So until you have that propellant in a case with a forward closer and a nozzle, it doesn't become dangerous. And the most dangerous part before that is the mixing and the casting, as far as I understand. So that is sort of why we're working with Aerotech. I'm like paying them to mix and cast these motors because they have a lot of experience, they have all of the tooling and all of the facilities set up to do that. And I kind of am like paying for their experience because if I make my own motors for this, the chances that it blows up go way higher. And we'll probably spend more money than we would if we just worked with Aerotech. Alright, gonna skip a couple here. Will your space shot have a heat shield for re-entry? No, it will not. It'll have a parachute. A pretty strong one, though. You do not want to go through something like what happened with the Traveler 3 launch. That is absolutely correct. You don't want to go through that. Did you fix the cams on Send It that popped out? I have not fixed them yet, and I will try to make sure not to crack the SD cards this time. I remember leaving a comment a while back, I think on a YouTube video, but are you ever going to try the mirror type camera mount, like a periscope? I imagine it might be more aerodynamically friendly. But the thing with the mirror is that I don't think the mirror is actually that much more aerodynamically friendly because of how tiny those camera bodies are for the run cams. It's not that bad. If I were going to use one of those really nice GoPro cameras, I would use a mirror setup though, because those can't stick out of the rocket. My face with Barnard Propulsion Systems outsources its propulsion systems. Will your drogues and your space shot need to handle supersonic speeds? Probably. Yeah, the thing, so, like, once a rocket starts tumbling, I haven't thought that much about re-entry stuff. We just need to get the rocket back in a condition where I can recover the avionics, and even if it tumbles on the way down, like, it's pretty easy for a tumbling rocket that is not stable to hit the ground at a reasonable speed, that won't, like, kill everything inside of it. Have you considered buying motors from someone like Loki Research? I know they make fat Q motors and stuff like that. Yeah, Loki is cool. I don't know enough about them though, and I think I wanted to work with a more like name brand company. It also like I talked to Cesaroni a little bit about it too. Different companies have different amounts of like commitment on different projects, and Aerotech was pretty clear that like they would be able to accommodate the workload of it, which is really cool. And that was a factor in there. When will Phineas fly again? I don't think it will. What class motor are you using? So for the space shot, it's a Q. It's like 84,000 Newton seconds, so it's right at the lower range. And all of that stuff is probably going to change bit by bit as the design moves forward. Oh, and it's 2 Qs. It's 1 Q at liftoff, and it's a 2-stage rocket, and then the upper stage lights the same identical Q. So this philosophy, the approach is basically make the same exact motor for your sustainer and your booster. And even though it's not the most efficient way to get to space, if you're making your own motors, it simplifies everything because you just need to make 2 of the same thing instead of doing the dev and test for 2 different motors. There is no Arduino full state feedback library as far as I'm concerned. I just wrote it myself. It's just matrix math. So what model of run cams are you using? Oh yeah, those run cam 2s are awesome. Oh, what are we doing now? This is a finishing pass, I think. Hold on. What are we doing here? Okay, yeah, I think it's just finishing. Yeah, we're just finishing, so we're getting the part out to its like final dimensions on the inside. And there's a couple of different versions of this finishing pass too, so it might take a hot minute. All right. The question about the run cams. The run cam 2 4K seems really cool. I used that on the Christmas tree, actually. I used the run cam split 4s and the run cam hybrid 4K camera. Those two are really great because they're very flexible and can go in really tiny places, and they have slightly different capabilities. If you're outsourcing your motor, why not outsource your shoots to SpaceX? I assume this is a joke. SpaceX doesn't give a shit about me. That is not a customer that is in any way worthwhile pursuing for them. Not a question, but more of a comment before I leave. Thank you for doing what you do. You inspire me every day. Thank you, Patrick. That's really kind. Appreciate it. Make sure when you static fire the motors that it doesn't end like that sugar rocket during the Phineas launch. Yeah. Yeah, the neighbors, I don't know what the neighbors think. I mean, I have nice neighbors. I talk with them. But I don't know what they will think when they see the space shot. Yeah, I don't know about that. Just read up on Traveler 3. Really hope your launch goes better. Also love your content. Thank you, Nickel. Yeah, Traveler 3 it's kind of heartbreaking, and the problem is it would have been wildly successful. I think they got to. I feel like their estimated altitude. Do they list it? Traveler. Because they know, like they have cameras rolling, and I believe they rocket. I believe they figured out 370,000 feet. What is that in kilometers? 70. Yeah, about 113. Like 113 kilometers. So they really clearly got to space on Traveler 3. And it's heartbreaking because they can't actually say with full certainty that they made it on Traveler 4 because they're within their noise margins on their sensors. So they can only say with like, when they say 90% certainty, it means the error which could accumulate from their accelerometer integration to determine if they got to space is great enough, that width is great enough that they could have actually gone to like 99 kilometers or something like that. Are there atmospheric heat and temperature concerns with the space shot? Yes, very. Mostly in the nose cone. The fins are going to be aluminum, and they should be fine. They should survive all right. The big concern is the nose cone, which probably needs an ablative coating. Probably. And the meat rocket doesn't need it because Mach 3 is survivable like by higher temperature epoxies. How workload intensive is BPS compared to other jobs? I am always working, almost always. I'm a little better about it now than I used to be, but I am always thinking about work in my head. So depends how you classify what work is. Did you buy a fourth axis for this machine and a mini lathe? I did. Why both? So the fourth axis on the machine helps make complicated parts where you have to rotate the part, but you're not spinning the part necessarily. And the great part about a lathe is that, especially with the manual one, I can just turn down little tiny parts as I need to. But the lathe is all like, they're slightly different tools and they're for slightly different purposes. With a fourth axis on this mill, you can't really get inside the part. You can only get around the outside. With a lathe, you could use something like a boring bar and get around the inside of the part too. Let's see what happens here. Okay, so this is our finishing pass for the base of the part. Which actually, the part goes a little bit lower than this too, so we'll have some more work to do there. But okay, have you ever lost motivation or commitment to doing your projects? If so, how did you gain it back? I've been having quite a hard time to commit to the stuff right after getting into college. I really understand that. I have totally lost commitment a couple of different times. Let me think about this. Yeah, I mean, I definitely the big one is when I took a break in 2020, like the end of 2020. I made that taking a break video, and then I didn't do anything for 2 months. And that was partially because of work. It's also partially because I was dating someone at the time and we broke up, and I was devastated about it. In terms of getting motivation back, the thing that works for me usually is tiny projects, tiny, super accomplishable projects, where you can start and finish it in a day. And I mean getting really realistic about it, because I feel like a lot of people who do rockets, certainly me at least, I way overcommit myself because I think that I can do more than I actually can. So I wanted to get 2 of these parts made, and we're only on the first operation out of 3 that has to happen for one of them. So we're technically 1/6 of the way through making these parts, and I wanted them all done today, and it's 8 p.m. So this was not an accomplishable goal that I set. But I think tiny projects and accomplishable goals are helpful for getting back into it. I'm not gonna put a link to it, but if you look up, I think the video is called "How to Build the Future" with this guy Sam Altman. How to Build the Future, Sam Altman. I think that's it. Yeah, it's called Sam Altman: How to Build the Future, and it's this video where he's a startup guy, and he talks about how burnout for companies is usually it's not that you're working too hard, it's that you're not succeeding. And you can really get your motivation back by getting some small wins. If you get a bunch of little wins, you can think it's really easy to feel motivated, yeah, I'm accomplishing stuff, I'm moving forward and making progress. I think that's why the gym is really good for some people. Exercise definitely helps. I don't know, not to get too into it, but I hope that helps a little bit. What's max Q for the meat rocket? I don't know. I haven't looked at Q yet. It's probably a good thing that I should probably know. How do you plan on getting the Space Shot rocket to the launch site? Right now, the plan is to rent an RV. I want to rent a big RV, and then I'm going to go live in the Black Rock Desert for 2 weeks while we do integration and all of the stuff associated leading up to launch. What do you think about the RunCam 3 light cameras? I have not looked at them yet. Save money on the Space Shot, use cardboard airframes. Balsa wood looks really well for hypersonic nose cone. I can't tell if you're joking. I actually think that's real though. It's kind of like cork. Although balsa wood doesn't flake off as well, so I don't know if that's a joke. Maybe that is a joke. How do you spin stabilize the second stage? You got it. Yeah, you slightly offset the fins a little bit. And if you do CNC too, it's really easy because you can just program that angle into your CAD. Do you think using a bunch of reaction reels to control a low-power rocket is feasible? Hold on. Anything is feasible if you design it correctly. Sorry, I'm watching the machine. I also think it's a really dumb way to control a rocket, but all model rockets are built for fun, so you could do it if you wanted. Do you think you plan on using 3D printed parts as your rockets go higher, get faster, and get larger, or do you still plan on CNCing? CNCing is good because you can work with harder and higher temperature metals. Plastics are not good for high speeds. Will you ever do TVC on HPR or anything like that? Hold on. Oh, okay. We're making some intense cuts now. These cuts are not as deep as I thought. Okay. I certainly feel like I've just been trying to do really big stuff in the short amount of time I have for small projects. Yeah, the tough part too is I sort of ignored this part, but you're in college too, so like you have a full-time job, if not way more, of workload already. So like I imagine you're just exhausted by the time you get to doing hobby projects. It's a lot of commitment. Since you have the best sense of style, what shirts should I buy? I do have the best sense of style. Look at this. I think this is from a website called Cry Now, Sob Later. Cry Now, Sob Later. Yeah, here it is. Here's where I got the TI-84 shirt from. Would you ever consider doing liquid fuel? Maybe after the space shot. I don't know. Is there any special technique to your editing? How long did you spend editing your Scout landing video? I think I spent like 2 or 3 days on the Scout landing one. You have a desktop mill, right? Yes, I do. I have a Carbide 3D Nomad. It is a little sad right now. I don't know what's happening, but the mill is not working great right now. But it has worked great in the past. Do you think a canard system similar to Phineas would be helpful to stabilize the second stage? Yes, if it works. And the problem is the if it works part, because aero control is really difficult. It's very easy to design something that hurts more than it helps on accident. So I probably won't do that. What CAD and CAM do you use? Right now, I'm a little bit between Onshape and Fusion 360. I'm kind of moving toward Onshape. And for CAM, I'm using Fusion 360. All right. So what we're doing here, you should be able to see it better on this cut. We're just cutting out a little bit more metal at the bottom of this. How do I get aerospace majors into doing electrical for rockets and coding, for that matter? Honestly, I do not know. Alright. Joey Barnard, my beloved. Howdy! Me and my friend built a 20-kilogram lift RC plane thinking of launching a rocket. Seems dangerous without TVC. It kind of seems dangerous either way, my guy. You should do what you want, so long as you are allowed to by your, federal and state regulations. I'm not sure that either one of those options is that safe, but it does seem If it's passively stable, I don't know. I don't know. I'm not liable for anything you do with that. This is a very big part. Any desktop mills you would recommend for beginners? I have a few parts that need milled, and I like the idea of being able to do it at my house. So, let's see. Well, okay. So transparently, I am sponsored by Tormach, and they sent me a very nice machine, and I promote their brand. I know that they're doing a desktop mill. Wait, is that true? Tormach. Let's find out. I think they have a desktop mill, but I have never tried it. Machines, mills. Yeah. No? Maybe? Yeah, they have a little desktop mill. I don't know. Desktop mills are kind of tricky. Like, excuse me. I found them to be very loud. I found my Nomad to be really, really loud. It did cut parts, and it had pretty good precision, but it screamed when it cut metal. A lot of desktop mills are built more for like wood and plastics, and if you want to do wood or plastic, most desktop mills are going to do it. The only thing I would say to probably not do is they sell these really tempting products that are basically a combined 3D printer, laser cutter, desktop mill, and maybe one other thing, router. Router. I feel like the things that you need from a 3D printer and the things that you need from a desktop mill are exactly in competition from one another. You want a really lightweight head and really good like travel and stuff like that on a 3D printer, and you want your rails to be pretty light, and then on a desktop mill, you want your rails to be really strong and everything to be super rigid. And I just feel like those combo machines are a little in competition with each other. Or like in competition with themselves. Whoops. Okay, what else? Oh, howdy, Kyle. What's up? You're welcome to rip off my landing leg design. Go for it. Ba-ba-ba. Will Ava be the primary avionics for the space shot? If so, will position and orientation drift from the MEM sensors be problematic over time? Good question. So yeah, Ava's going to be primary in control for Space Shot, probably. We will also probably fly other commercial altimeters, because I love Ava, I'm really proud of the design, I think it's a great computer, and I am also a flawed human being, and I make a ton of mistakes all of the time. So having Ava in total control and nothing else is not a good idea. So we'll put some commercial stuff on there. And then the drift from IMUs and stuff like that, like Ava doing its own integration is all well and good, but as long as we're recording raw sensor data, I can use whatever I need to with the raw sensor data to find out if I made it to space. I will also say, it is really hard to get COCOM unlocked GPS to validate that you made it to space. It is not impossible. It is not impossible. It is just really hard. Okay, so this is our... I hope this works. This is called a radial pass. Is it working? I think it's working. I'm taking these passes really slow. This is basically, if you were on the stream yesterday, I did these parallel passes where this ball nose end mill just grazes over the part and it creates these really nice ridges on the part instead of having this rough finish like we've got right now. And so with this, what's happening is we're just barely touching the material. We're taking away just a little bit at a time, and what we're going to be left with is a much smoother surface finish on these angled parts. Is it necessary for flight? No. Are we making a meaningful weight reduction? No. Does it look cool? Yes. Yes, it does. Alright, it's most definitely working. It's just I'm taking cuts way more shallow than I actually need to. We don't even really need coolant for this. You can hear it cutting. That's so quiet. It's wonderful. I'm just going to leave this off. You know what, too? We're not throwing chips everywhere. This looks gorgeous. Yeah, this is great. You can hear how quiet the machine actually is. The coolant, when I turn that coolant on, that's the loud part. Okay. Got those LEDs inside the mill. I'm falling behind on chat. Sorry, folks. All right. How do you attach the meat to the meat rocket? Wouldn't you like to know? No, it's going to go in the nose, and then we're going to put a tiny little cover over it. I think I want that to be copper, too. We'll have to do some... the design is not done for the meat enclosure. The Tormach is capable of faster cuts than this. Oh, for sure. Way faster. I think I'm going to speed it up. I just wanted to finish this path before we did that. This is a more reasonable speed. grabbing a couple little clips along the way. Yeah, I mean, we could go 1,000,000,000% faster than this. Whew. All right, router. Hardly know her. Yeah, okay, Jefferson has the right idea. I gotta catch up on this chat. Those combo machines are terrible at everything they do. Yeah, I agree with this. A big question, if you get one useless superpower, what would it be? The superpower to control what happens in my digestive system. It is crazy how much my stomach hates the things that I put in it. Even sometimes normal food. And I wish I had more control over that, because bad digestion will like totally ruin your day. Which part is currently being milled? So this is a attachment point that connects to the airframe of the rocket. We're going to mill out the circumference of this, but that's the last step. So we're doing this operation, which is actually almost done. Once we finish up these spars, we drill a hole through the middle, then we flip the part over, re-index the machine. We drill out the backside of this. Then we take the CNC vise off the mill, we put this on the build table, and we take this 3/8 bit and we mill it all the way around the outside, and then we have a finished part. Anyway, it's hard to describe what it does, but it basically, there's this camera section, right? And the camera section spins. There's this whole spinny part. But all of the load of this 4-inch rocket has to travel through the center of this spinny part, because the spinny part isn't taking any of the load. That's a really hard mechanical thing to design, because you're taking the load from this like big diameter circle which can resist forces and torques at 4 inches. That's really easy. And you bring it down to 2 inches and it's like, okay, we need a tube that is really, excuse my French, but really fucking strong. And you need to take that tube and then translate the force that goes through that back into the 4-inch airframe. And that's the step we're working on here. This basically connects to a small tube to a big tube. Okay. What is the VFR 60 on the Z-Cam? Oh, I'm so behind. That means variable frame rate. So I'm going to stop recording now. VFR 60 means variable frame rate. And if I open up the menu, can you see this? No. Here, I'm going to turn off my... Let's go over here. Hold on. Okay, so in the menus, we have our project frame rate, which is 24 frames per second, which I love. And then under that, you can set a variable frame rate. So 24 frames per second is what all of these clips will show up as in my computer. But then, if we go into VFR, all of these different frame rates, I can actually set to what I want to record it. So I can go up to 120, at least at this resolution, and it'll still spit out 24 frames per second, and then I speed that up to actually make what I want. But basically, it's a way of recording slow motion. And then I can also turn it off, and that VFR would go away. Okay, go back up here. What's the stupidest project you've ever thought of or done? RRTV or Dart? Don't count? Those are the stupidest projects. Okay. Hold on, I missed a couple. Ava is good, but it also violates your IMU selection guide. I don't know what that means. Will you lose connection from the vehicle in space? Probably. We probably won't have comms from the vehicle in space, but we should get it back on the way down. Stupidest project? I don't know. It really should be Dart or RRTV. Both of those are super dumb. I don't know that I have a good answer for that other than it. You should beg Tormach to send to the 1100 MX. Yeah. think about that a lot. The 440 is really good. It's especially once we start making 6-inch diameter parts, it's going to start pushing the limits of the machine a little bit. It's not really about the speed for me. It's about the work area. Okay. What's your step over on this toolpath? So, Sumark, the interesting thing about this is, so it's a radial toolpath, which means your step over is expressed in degrees, and I think I stepped over at like 0.1 degrees. But basically, all of this parallel motion is going out from the center of the part. So it's not actually parallel, I guess. But Austin B, glad to catch this historic moment. Shout out Austin B for real. If you could redo one thing in your rocket career, what would it be? I would finish Scout sooner. I waited so long to fly Scout E a second time. And I would just get a little braver about losing rockets, I think. I would also not... I would redo a lot. I would spend way less time on Lumineer videos. So, like, I should have just destroyed my life for 2 months and done all of those videos in 2 months. And then taken a big break. Instead of doing what I did, which is, like, half-assed work on it for 5 months. This is a flat end mill with a tiny radius. It's definitely not the ideal tool for this. I just want smooth surface finishes, and I know this will get it. Oh boy, okay, I gotta start really going faster here. Favorite song that I've made or posted somewhere on the internet? I really like My Thoughts, and I really like Machine. I made a bunch of different versions of Machine, and I quite like that one. Debris cleanup, let's see. How often do you find shards of aluminum in random places? Literally all the time. Aluminum is part of the house. How did the Easy Mini perform an avalanche? Great, I love the Easy Mini. It's a really good altimeter. If you're going anything below, like, I don't know, what is it, 30, 50,000 feet? The Easy Mini is great. Super tiny, totally works. You don't even have to program it out of the box. Like, the default settings are fine. Steel is probably the worst because it hurts the most. Yeah, aluminum is very common. And steel chips are... I have not milled steel on this yet, but I have heard that it's not fun. What's your favorite real rocket? I do like Electron a lot. I'm quite into how batshit insane Starship Super Heavy is. Like, I'm definitely not... I used to be more a part of the cult of Elon, and I'm not so much a part of the cult of Elon these days. But Starship Super Heavy is batshit insane. It'll probably work. Like, they'll make it work. But, like, very... very fun to watch that development. Cutting that big of a hole to deploy Starlink satellites is insane to me. That's the most insane decision I've ever seen, is like knowing that your load from all of that top part of the rocket has to go through you cutting like a third out of the circumference of the rocket. That's insane. Do you still have Scout E? I would love to see a pic of Echo Scout E and Scout F all together. Scout E, I do have. It's in a box in the back room, and it's in 2 pieces, and it's all crunched up. Couldn't respond earlier. Heard that F360 is good for cam. What size fluting is the end mill? This is a 3-flute, 3/8 cutter. So on the BPS wiki, there's an IMU selection guide saying the BNO. Oh, it does. Okay, yeah, no, I get it now. Do you think you'll ever build Big Scout? Maybe. We'll see. What coolant are you using? It looks like a mist system. Right now, I'm using no coolant, but it is a mister. It's a fog buster. And then the actual coolant is this stuff. is Qualcomm Extreme Cut. This bad boy. All right, almost done. I think we're changing tools next up. We should be very close to done here. Okay, here we go. Now we're cooking. Okay, so we need a new tool. We're going to do the T7, which is the spot drill. All right. T7 is the 90-degree spot drill. Awesome. Whew, this is pretty smooth. Okay, and we're just going to spot drill that area, although I do want to get rid of some chips just so it looks nicer. You like take pride in your parts, you know? Okay, spot drill time. Besties, you ready? Cycle start, insert T7. Not need coolant for this. Wow, very exciting operation. Okay. Next up, the drill. Oh no. Oh, this is awful. Oh, it will fit. Woo! Okay. This is terrifying, actually, is the word I would use. Yeah, I would call this terrifying. Okay, I also want to get that coolant in there. I'm gonna open this up. Let's open up this pit! Okay. So T11, and keep the feed rate a little down for this because I don't know how to drill. And let's hope that doesn't bite me in the ass. I'm gonna record in case it goes wrong. Not that I ever do anything that goes wrong. Okay, here we go. Uh-oh. Rapid move would exceed machine position limits in Z+. Damn it! Okay. Exceed machine position limits in plus Z. Okay. Oh, wow, it just quit the program. Okay. Well, it really doesn't like this, but we can just drill it on our own. We can do conversational drill. I mean, we're already centered because we haven't moved. Like, that is a centered 3/8 hole. I say let's do it. That's not good. That's a terrible sound. Woo! I think that should be enough. All right. I'm calling it. Nobody move. Oh, okay, hold on. It's gonna get real splashy real quick here. It's everywhere. Damn it. That is very funny. The good news is it's just coolant, which is like not that bad. It's just that it went all of the places I didn't want it. Okay. Let's take a look at what we did here. For this center part, I think we have enough depth. Yeah, this is plenty of depth. We will cut through on the other side when it's time to do that. So we're all good with this tool. Thank goodness. That is not a fun operation. Okay. Now, let's get this out of here and turn it over. Now tool here. You know what I might do is vacuum some of this up too. All right. Good enough for now. So the tricky part here is that we accidentally folded over this, which I really hate. I think the right move is probably a deburring tool. I also just put like the 3/8 cutter in there and go to town on it. Let's try that before we take it out of the vise. I want that side flat. All right. No coolant. Alright, so what I'm trying to do is not cut the part, but only cut the burr. I could do this with a deburring tool, but I'm a little too stubborn for that. Alright, I think I got it where I want it. Yeah, that's good enough. Okay. Oh, that's perfect. That is exactly what I wanted. It's a totally flat surface. Okay, great. So now, let's go up here, get this tool out of here. Get an empty thing in. And we can clean up the backside. All right. That needs to be air dried. All right. So we got this part, right? Looks pretty good. Now we got to get the other side of it, and then finally we'll cut out this part. But we gotta get the backside first, and pretty sure the best way to do that, we index off of this, so we should index off of this for the back half, and then just center on the other parts. Looks pretty good though. Okay. Oh, look, I almost cut through with the drill. There's a little bump at the top. That's funny. Awesome. All right, so first thing we're going to do is get that probe in there. And find our center, because our center has changed. Not by much, but it has changed. Okay. All right, so we're going to take our 0 over here. Find the middle, so we're in tool 99, status, okay, find x plus, okay. That's a pretty shot. And then we find x minus. I actually do not trust that. Let's go down just a little bit. .9835 divided by 2. So we're going to 1.9917. Okay, 0. Great, that's our center there. Then we need to go back to front. Go here. Oh, no. Wait, how did this happen? Oh. We have a lot of material back there. Hold on. I think we are... Try that again. Must take machine out of E-stop. Oh, I E-stopped it, didn't I? Awesome. That's really cool. Oh. We hit a limit switch. Awesome. All right, this is great. I hate this. Okay. Limit switches. Reset. Okay, now we're out of E-stop, put the limit switches back in, and our X and Y both lost reference. So we have to re-reference both of those, and then we should re-zero. That sucks. The realities of machining are not that glamorous. Okay. So let's retake this 0 here. Cool. That's good enough. Probe EPS, find the X plus. Okay. Find X minus. Here we go. 3.9853 divided by 2. 1.9926. Awesome. 0. Okay. And that looks like the center. Now, take it this way. And probe Y plus, no, Y minus. There we go. Much better. Just had too much stuff down there. Then we go find Y plus. .8666 divided by 2. 1.9333. So y-axis, go to 1.9333. 0.9. Awesome. 0. Okay. Thank God. That's a lot of work. All right. So we zeroed this in. I'm going to go generate and send the toolpath to this. Then we can do the backside of the part. And after we do the backside of the part, we can finally take off the circumference. I'm committed to trying to do this whole part in one stream. I can't believe I thought I could do 2 of these. They're big parts. So give me like 1 minute and 36.8 seconds, and I will be back here and we will start this operation. BRB. Where's my phone? Here we go. Okay, I'm back. I'm better than ever. And I brought a bowl of fruit. I'm going to eat some fruit while we do this next op. Because I'm hungry. Oh. That fish was 1,000 times bigger than I thought it was. Okay. So. Oh. A bit. Let's zero it out. Where is that little piece of paper? Here we go. Okay, this is really inconvenient with the camera. Okay. That is our Z0 if we have tool, this is tool 1. Offsets, tool 1, 3/8, yes. Tool 1, Z0, new G code, airframe attachment, bottom, load. Okay, pretty simple op, I can show you what we're doing. We've got nothing too fancy going on. We're coming in, doing a similar thing as the other side where we're pocketing out this stuff around the circumference. We're pocketing out some of this right here. And we're also doing a little bit of a facing operation. I don't know why we're doing this. I think I wanted a nicer surface finish. You know, it's a little hard to tell with Joey B what is really going on, but let's just send it, see what happens. How about that? Here at Joey B CNC, we don't really play by the rules. We play by our own rules, and we get in trouble because of it almost every single time. Okay, Resetting our feed speeds. Door is closed. Let's boogie. Alright, I think I just wanted a nicer surface finish. I think that's what I did here. Whoa, what is up with these Tinder hot... What is going on? Hi, users. We got more hot girls in the chat. Oh my goodness. How are all of the hot girls getting here? Perry, I'm making you a mod. You're a mod on the other channel too. We don't have a whole lot of mods here. What CAD software is he using? If you put a question in like the last 20 minutes, you can just re-ask the question. I'm too far behind in the chat. Right now, so these parts are in Fusion 360, but I'm also moving to Onshape. And either is a fine CAD software. Hot girls and carbonated milk. Oh my gosh, my fruit! I forgot. I brought myself some fruit because I got a little hungry. Also, I almost knocked my dial indicator off the desk, which would have been big sad. Some would even say like enormous sad. How does this work? Okay. Oh boy. Okay, now we're plunging in. These passes should be pretty easy. Still going well. Where did I get this shirt? If I paste this, I think it'll work. Yeah, here we go. This is where I got the shirt. Do you think single end dual deploy or dual end dual deploy is better for recovery? I usually call it dual sep dual deploy or single sep dual deploy. Whatever you want. I understand what you're asking. Who is that? It's like a seed in there. I quite like dual sep dual deploy, but it's mostly because I did single sep dual deploy on Lumineer, and that really didn't work. But dual sep dual deploy is really easy in terms of your lines diagram and how your chute's attached to all of the other various things. Fruit bowl looks tasty. Oh my gosh, it's Andrew Adams! Hi, Andrew Adams! The fruit bowl is okay. I wouldn't say it's in my top 10 fruit bowls. And frankly, when you buy something like this at the grocery store, you could get it way cheaper by like cutting the fruit yourself and get a lot more fruit. But I was at the store and I was really hungry and I made some impulse decisions, and this was one of them. And it's okay. side. I'm pretty sure we could take these cuts more aggressively, but I'm kind of fine with how it's happening right now. Okay. No more fruit bowl. Close-up time. So pretty. All right. I've missed some chat. You're welcome to ask questions again. I'll try to get to some of these here. How did you learn CNC milling? Taught by yourself? Okay. One of my favorite channels on YouTube is called NYC CNC. It's a little bit of a mouthful, but they make some amazing videos on like how they do CNC operations. It's also a really fun channel to watch because when they started, they were like, it was just a dude, I think in his garage with a really tiny mill. And now it's a massive machine shop. Like they do all sorts of stuff and they've got these great tutorial videos. So I'm like self-taught, but a lot of it is NYC CNC. And then Tormach has some good resources too. But yeah, machining's kind of daunting to get into it, and NYC CNC does a good job of being like a friendly teacher. I think that's so important in teaching people how to do things, is not making them feel, never making the person you're teaching feel dumb for not knowing what you're teaching them. Like when someone says, oh my gosh, I don't know how to do this, you go like, oh, don't even worry about it. Like, sorry, I had a lot of fruit from the fruit bowl. You go like, don't even worry about it. Like, it's gonna be great. You're totally gonna get it. and encouraging them. And NYC CNC is really good for that. All right. Mr. Adams doing some CAD for some fun rocket stuff. Mr. Adams will be out at Rock with me at Rockstock when we fly this thing and send it. Adams is doing his own project that also has a whole like tech development path. If you want more details, I think you should be able to click on his name and it will take you to his channel. I can't do it from my thing. Hold on. Let's just do this right now. Ba ba ba. Here we go. Okay, I'm going to toss this in the chat for anyone who's interested in more rocket content. But Mr. Adams is doing a really cool project, and I won't spoil it, but if you want to know what it is, you can click on that. Alright, favorite fruit? What did I have the other day? It was some type of pear that was really crunchy. It was like all of the good flavor of the pear and none of the gross mush that comes with pears. How long do you plan to coast before relight on the space shot? Does the booster Q cause the rocket to go supersonic? If so, do you plan on coasting until low Mach to keep from going transonic twice? That's a great question. I can't remember the burnout speed of the booster, but I think it's like lower than you would think. We must go supersonic. I'm pretty sure we don't relight until like 13 kilometers, maybe 15 kilometers. Honestly, the flight profile hasn't been sketched out that much. I played around with it a little bit, and most of the purpose of playing around with it is not so much to get like exactly where we want, but to know like, okay, these motors will definitely get us to space, and then we can figure out the details later. How do you know that the opposing sides of the stock are parallel? That's also a great question. Lots of good questions today. I know because I milled them. Yes, I know because I milled both sides. So I milled one side, which does not make them parallel, and then I flipped it, I put that other side over, and I milled the other side, so that's how I know they're parallel. Great question. Do you think they'll fly... Oh, this is a question for Andrew. Feed rates and RPM right now. I don't know feed rate, but RPM is about 6,000. Oh boy, I'm quite behind. I'm gonna skip a couple. Okay. Kiwi is the best fruit. Kiwi's pretty good. Season's Eatings 2.0? We would like to. There's a lot going on this winter, so... Between both Zyla and myself and all of the various friends that we are involved with, like, for making Season's Eatings happen, there are a lot of moving parts. I will tell you this. The plan right now is that it would be fun to do a Christmas tree, another launch, and it costs almost nothing in terms of parts. You just need to have a motor on hand that's ready. I have a motor on hand that is ready in case we do a Christmas tree. But there's a lot going on, and there's a good chance that Meat Rocket takes precedent, or who knows what. We might do a tree. We'll see. Oh, shouts out Hannah. Hi. Hannah says, brrrr. Would you rather have bacon, unlimited bacon but no games, or games, unlimited games but no games? What? Am I high? What's happening? How do you come up with your rockets' names? I don't know. Hold on. This is a really deep cut. Okay, this is as deep as it goes. further into the part than I thought we would. Or like, than I thought it would look like. Can I recreate Season's Eatings on a smaller scale with an F-footer? Yeah, of course. I mean, are you talking about logistically? It's going to be really hard to lift a tree with that. If the question is ever, you know, is it okay if I recreate this, or is it okay if I rip off your design or whatever? The answer is like always yes. You're welcome to use the things that you see on my channel and like build your own version of them. That is not at all a problem. Ivan or Ivan says, please say my name. Hello, Ivan or Ivan. When will your next video be? It might not be until November 15th. I have a video that's due November 15th, and then I have a video that's due November 19th. And I might have another video that's also due in November. November might be a great month for BPS videos. October is pretty much nothing. I do not know about HPC or trochoid milling. I don't think I know about those. Carbonated milk is RCS fuel. Good idea, buddy. Would it be possible to build a rocket out of a piece of ham? Like the ham you cut at Christmas. Spencer, you've asked such a wonderful question today. You asking if it's possible to make a rocket out of an entire Christmas ham is a better question than I think you realize. This has actually happened. There is no evidence of it online. We made sure of it, and it never actually flew. I can tell you, it is so entirely possible to fit a 3-grain 38mm motor inside of a Christmas ham. It's absolutely possible. I would go so far as to say that someone has probably done it before. But who's to say, right? There's no evidence. You won't find anything online about it. Certainly not if I look through my camera roll would I find, you know, any type of like Christmas ham related type things, right? Like that would be so surprising if I found any types of like Christmas ham with a rocket motor in it type thing. Oh, actually, okay. No, I don't have a picture of the ham with the rocket in it. I do have a picture of a ham without the rocket motor in it, and it doesn't look very good. The ham leaves a really unsettling hole in the rocket motor leaves a very unsettling hole in the ham. Anyway, thank you for that question. Joe, what's your opinion on the state of SLS? My opinion is that it's in the VAB. That's my opinion right now. You know, and any opinion beyond that is purely speculative and hearsay, and frankly, who's to say? How deep does this go here? Okay. Hey Joe, currently working on. Oh wait, hold on. How are you so good at so many things? The trick is that I'm not good at a lot of things, but I do a lot of things. And it's easy to make you look good at things when you point a camera at it and have nice lighting. Thank you, though. That is very nice. Currently working on the design of a hybrid engine, your favorite type, feed system, and nice things from the company. Oh, thank you, Rowan. Rowan. Alright, is the ham the propellant or is the ham the rocket body? So the ham is the rocket body. I'm gonna look again. There's a possibility that I do have a photo. Yeah, I thought I had a photo with the rocket motor in it. Hang tight. This is very important. Okay. No, I don't have one with the rocket motor in it. I do, however, have... Listen. Listen to me really close. Okay? I need you to understand this. You didn't see anything. You did not see anything. That is not a Christmas ham. There was never a 38 millimeter 3-grain case in there. Okay? You're making this up. I'm telling you, the hole it leaves is really unsettling. It did not fly, but we did get the rocket motor in. This was a while ago. Okay. The ham should stay a mythical beast. Not that Andrew Adams would know anything about the ham, right, Andrew? You certainly wouldn't. You would have no idea what this is about, right? Right, of course. Is it safe to use a fire extinguisher for model rocket? I've considered using one in my house. I mean, I think in terms of safety, like if you're thinking about safety, should not be rolling. If you're thinking about safety, then I guess yes, you want to use a fire extinguisher. In the event that you need to use a fire extinguisher, the safer thing to do is use it, usually. Cheese rocket going to the moon made of cheese. Any plans on rocket powered Christmas tree 2.0 this year? Yeah. I think I talked about this like a few minutes ago, but we might do one. It's a hard maybe. Zyla is super busy right now too, and so she's got a bunch of stuff going on. She's traveling a ton this year, so like she's got hella commitments. And then I have Meat Rocket, which like Meat Rocket was supposed to fly in November, and now it's probably December. So it may be a little bit tough to get the Christmas tree to happen. But I'll tell you this, I have a motor for it, and I have a desire to do it. It just depends on whether the schedule allows it. Alright. Ham rocket is the single most legit question. Yeah, clearly you know nothing about this mythical beast. It's unsettling enough. Alright. Let's see. Milling with 1,000 inch per minute. Is that like one of those Datron machines? Is that what it's called? It's like a Datron mill? Datron? Yeah, is that one of those? Those things are crazy. Would it even be Season's Eatings without Zyla? I don't think so. I think Zyla's got to be part of it. It's a joint project. Alright. We can speed this up. This does not have to be this slow. Definitely be taking deeper cuts. Probably should have been doing that, but it's all right. All right. Do I still have the Season's Eating suit? Are you kidding me? What kind of question is that? Of course I still have that. Sup, Joe? Hi, Harry. How's it going? Please forgive the question, but I didn't see you probe the top of the block. Do you know how deep? How do you know how deep you're cutting? Okay, yeah, great question. Perry did answer it, but I'll also answer it. So we probed the sides of the block to get the actual center because the work coordinate system, the way I set this up is I want it in the center of the block. So we probe one side, probe the second, divide it in two, and then sorry, brain fart. And then for the top of the machine, I don't have the probe set up correctly in terms of its vertical height, so it's easier to just use the tool because the tool is the most true measure of like what the tool length actually is. The machine has some knowledge of tool length, but it's easier to just dial that in with a little piece of paper. What is the purpose of the shape? Oh my gosh. What is the purpose of the shape we're cutting here? So this is 1 out of 2 parts. I'm going to make a second identical one, which is great, given how long this operation is taking. But I am going to make a second one of these, and this is basically the top and bottom of the camera mount that is supposed to spin around the rocket. So the part has to be really, really strong because all of the bending loads to the rocket, they all travel through these pieces, and so it's important that these pieces interface really well with the tubes that they're connecting to. Okay. Have you seen a new Metal X 3D printer? I have not. A rocket made out of oh my gosh, a rocket made of super glued together ramen. That sounds fun. You know what sounds better? I really want to do a hot glue rocket. And what I mean by that is you start with an Aerotech DMS motor, a disposable motor, and then you just start gluing around the rocket. You make fins out of glue. It's the OG additive manufacturing. It's a hot glue rocket. I think it would look awesome. Lucien says, I have to go to bed now. I got school tomorrow. Bye, Joe. Thanks for stopping by. Thanks for hanging out. I feel like somebody can make a playlist of rockets made of food. What is the object or device that's at 50C in the top right? 50C in the top right that's the camera sensor temperature. So the sensor on this camera up here is getting pretty hot, and that's just the temperature of it. Thanks for answering with the channel. Thanks, Brian. Won't the spinning act on the rocket like a reaction wheel? Yes and no. All spinning things have forces like reaction wheels, but the wheel here is something on the order of a few hundred grams, and the rocket is like 23 kilograms or 22 kilograms or something. So the spinning should not meaningfully impact the roll of the rocket. Oh, shout out Duncan. This is all to avoid the 3D camera blend lines. But also, like, 3D cameras don't work at a 4-inch diameter unless you have separate lenses. So if you want to look down the rocket, if you want to see the bottom of the vehicle, which I would like to, you have to have the lenses peeking over the side of the airframe. And so you either have to have a 3D... Oh my gosh. You either have to have a 360 camera that is naturally like 4 inches in diameter and can take the load of the vehicle, or you have to have separate sensors and lenses that you can place around the circumference, which is also totally possible. They make 360 cameras that are like that. I just hate the stitch lines too. That's gonna go to bed, but watching Joe cut metal is a way better use of my time. I agree. I need some oh, I'm late. What have I missed? So many things. Mostly just cutting metal though. I need some fiberglass airframe. Where did you get yours for Send It and Avalanche? There's a couple of different places you can get fiberglass airframes. Most of them come from the same original supplier. I get mine from a couple of different places, but I think the closest to the source is going to be Wildman Rocketry. I've gotten some from like Mad Cow Rocketry before, but it's like wildmanrocketry.com or something like that. And they're pretty good. They work pretty well. Oh, sorry, Trevor. You did say the stitch lines. I understand now. I sort of forgot the original question and then just restated it. Getting there. I am going to start on another operation over at the drill press there. I'm going to make a waste board that we can mill around the edge of this thing on. I'm a little sketched out by the work holding for this, and you'll see why shortly. Gonna hit the material? Huh, okay, hold on. Good. The waste board is ready. We'll see. I'm going to see how I feel at the end of this, and we might try to finish the part. What do y'all think? Should we? It'll probably be like another hour at least to finish the part. Should we do it tonight? Is it worth it? Oh man, Guy says, love your channel so much. Started my university's rocket team because of you. Thank you so much. What's the diameter of the end mill, roughly? This is a 3/8 inch end mill. Make sure you're not getting material buildup again. Wouldn't want to limit the y-axis. Good call. Yeah, that's a great call, actually. I'm going to do something a little sketchy and clean it up. Okay. People think I should finish the part. I'm inclined to believe. Sorry, oh my gosh, I am losing my mind. I am inclined to agree. We've come this far. There's a lot of chips in my hair. Oh, it's crunchy. I think I might take a shower after this. Alright. IDK, if you ever gone to KSC, but do you have any recommendations for where to go? I have gone to Kennedy Space Center a couple of times. I love it there. It's very cool. Make sure you go to the Saturn V Center. You have to get on a bus to go there, but it is so totally worth it. Saturn V Center is great. There is an actually, it's changed now. They opened up a new exhibit, so there's an actual Falcon 9, or it's a Falcon Heavy sidecore. Oh, we're done. Anyway, spend the day at KSC and like do all of the stuff you can do, because there's tons of really cool things there. All right. This is looking lovely. I am going to vacuum this up one more time. Here's what I think. I think we should finish this part. I also think I have to pee really bad. So I'm gonna go to the bathroom. We're gonna come back. These tool paths are pretty much ready to go. I just have to double check tool height and things like that. But it should be fine. Should be all Gucci. You know, we can just do it now. Tool height on this is, or tool clearance at least, is a little over 1.5, 1.57, let's say. And this is not going to cut it. We need a longer tool than this, or we need a longer stick out. Damn it. So annoying. We could use a 1/2-inch bit to do it. But then I'd also have to put it in a new holder anyway, so what's the point? Okay, I'm gonna go to the bathroom. I will be back in a little bit. I think we'll extend this slightly so as to be able to clear the part, because right now we're gonna collide with the part, which sucks, and it's gonna cause all sorts of problems for us. Gosh, this is going to be really pretty when it's done, though. Okay, I'm going to go to the bathroom. I will be right back. Do not even think about leaving. Don't even think about it. If you think about it, you have to report it in the comments too. You got to tell me that you thought about it. All right, BRB. Okay, besties. Let's boogie! And by boogie, specifically I mean, let's find out how long this tool needs to be. Alright. This is 1.8, let's like 1.9 inches, almost 2 inches. So what we are going to do is come all the way on over here. There's a couple of sketchy things that are about to happen. And you're going to witness it. So we're looking for 1.9 inches on this bit. Can we get it? I do not know. And if I'm to be completely honest with you, I'm actually not that confident we can. I forgot lefty loosey tighty. Totally classic move. Classic Joey B. Alright, that's 0. We re-zero here. We need to go to here. How much range do we have? Oh, we'll be totally fine. Yeah, let's, this is more than enough. Cool. Trying to get them nice and tight. There it is. It's a good tool. Okay, so now we measure from the base. We go 0. That was tilted. Go 0. Up here. Get to the top. 4.1795. So now we go into Path Pilot Controller. There's the lathe. Wait, it's a lot of work to move these cameras around. I'm losing my mind. I'm literally losing my mind. Okay, so see here it says length. I go 4.1795. 4.1795. And because this is a single tool, we didn't really need to do this. Excuse me. No, that's stupid. We totally needed to do this. Okay. Now we go into File. This is all of the stuff that ends up on the machine. So like we have Meat Rocket, Scout F, Send It parts. Like these are like bulkhead things for Send It. If I load that G code, you can see like here's how we milled the bulkhead for Send It. It'd be fun to do more videos on this. Milled parts for my friend Patty. Here's the thing from the throttle control stuff. These are parts to make the throttle control, G-code to make the throttle control brackets. Okay, let's stop dillying and also dallying. Meat Rocket, camera spinner, airframe attachment, circle contour 1. This is what we want. And that's all we're doing here today. The tricky part about it is the work holding. So we've got 2.01, top to bottom, and the top is, I have to double check how the top gets referenced, but I think it's just the top of the part. Yeah, I'll double check that in a little bit. Let's get this show on the road. Okay, so we can get the part out of here if I can find the wrench. Woo! It's already a lot lighter. So you got this side and this side, and then we gotta cut it out. Leave it there for now. And now, we remove the vise. We don't need it for this part. Because if we used it, we would crash into it. Here's our parallels too. Save those. Okay, hold on. Okay, this is gross. It needs to be hella cleaned. It's also 300 million billion trillion pounds. Thank goodness this isn't stainless too. This would hurt very badly. Okay. We're gonna do, here's my IPA. Huh. All right, well we can do without it. I think I need to get more IPA. You know, need more India Pale Ales in this workshop. Okay, so we're going in the center here. This piece. This is called our wasteboard. So we're going to cut into it a little bit intentionally. Now, there's a part of this I'm not super sure about. Okay, we can just get rid of these. And it's the work holding. So my plan, which I don't know if it will work. My plan looks a little bit like this. And then we bolt it down. What do you think? My plan also involves a big washer. 1 second. Okay, check this out. Washer goes down like that. So the washer goes down, we mount right here, and then we pull up super duper hard with this. And then we'll dial it in. We'll use the dial indicator to make sure that we're all straight and narrow and level and whatever you want to call it. But we take this, right, and like really dig it into the wood. I think it's gonna be pretty hard to move. We have to come out of this actually because I have to dial it in, but damn. Okay. What do we think? How are people feeling about this work holding situation? Have you turned to the stock where you recentered using the size? This will only align with the previous center. Yes. So we're going to dial indicator it in. Okay. That's the way cover protect. Could you not part it off on the lathe? Yes, you could. Oh, you know, I guess. It's a pretty big part for my tiny little lathe. OSHA would love this. Sumark hates it. Should be fine. I've seen it done a lot worse. You do what you have to do, it'll do something. All right, well, it sounds like people are in reluctant consensus, which is great. That's good enough for me here. When it comes to milling, I don't expect to get any more out of any good machinist than, well, I guess it'll work. I feel like that's about as good as you can ask for with any good machinist. Oh, I also rotated 90 degrees. I want to do this just so I'm sort of making sense. Yeah, I think it's actually this way to remain consistent with all of the other setups. So then I'll take my measurement off of the back half. But before I do any of that, I need a dial indicator. All right, we're gonna change views for this. Okay. So, first on the x-axis, I'm going to bring it in a little bit, actually. Oh, this side is not... No, we're going to dial off the front because that is the smoothest surface. Okay. Getting a little confusing here. But this will allow you to see it a lot better. And also come down to this. All right. Bring it down a little bit. Shouldn't go anywhere. Okay. Can everyone see this? Okay, we're going to come in just a little bit. And now we're going to go along the x-axis. All right, so we're pretty far out right now. Actually, this shouldn't matter. It matters a little bit. Okay, so we're sort of at the bottom. All right, getting better. Now this side's high. So we need to come up to maybe the middle there. Okay, I'm going the wrong direction. How about that? That's pretty good. These are tenths, these are not thousandths. I think this is good enough. So then we clamp it down. I don't know how hard I want to go with it, but it's only one bolt. That's our only work holding. So I kind of want to go a little hard. All right, no harder than that though. Cool. So now we have to zero in with the probe. Okay, so we're going to go here. Where's the mouse? Okay, offsets. Probe. Oh, you're in the wrong camera angle. We're going to find y plus. Oh, which will need 9? 9. Find y plus. Okay, and find y minus. And now we're going to go to 3.8689 divided by 2. 1.9344. 1.9344. Boom! On the dot! Okay, let's take the other side now. Come over here. Actually, we're going to do it on the back because that's sort of where we did it last time too. And we're going to go offsets, probe, find x plus, up, and find x minus. .9836 divided by 2. Okay, 1.9918. 991. Boom. Okay, that's zeroed. Got our y zeroed up here. Whew, okay. Y'all almost ready? It's a lot of work. I need to check one more thing in the tool path that we have set up, and then once I've checked that, which is mostly just like where is our reference height, pretty sure it's at the model top here, so we should be fine. But just in case, I'm going to double check that, and then once we're done, we can mill this whole thing, and that's the whole part. All right, BRD. Okay, we're all good. I did the thing that I was hoping I did, which is that I set the reference as the model top. Pretty sure I tightened this down. Yeah. Okay, we put the new tool length in. Right? In our offsets on tool 1, 4.1795, which is correct. So now we're going to zero it in. With this little piece of paper. Okay. That's 0, or close enough to it at least. C0, and that's tool 1. Whew. Everybody ready? I think we're good. Should we send it? This is the last op here. All right, is everyone good if we send it? Tell me if I should send it or not. Which is a stupid question, because I'm just going to send it. Send it! All right. But an indicator tool holder is a fine way to center hold. Oh, okay. Does anyone have any problems? How sad would I be if it spun? Yeah, Sumark hates it. It's so disgusting, it's intriguing. Listen, I don't think it's totally concentric. And yet here I am doing it. All right. Joey B, don't be flippant. Challenge. Impossible. Yeah, I don't think it's totally. I hate the way you took offsets more. What do you hate about it? You should be finding from the center of the hole. Oh. Listen, you're probably right. But it's too late now. All right. Circle contour. We have tool 1. I'm going to roll in this camera. The sides aren't vertical. No, it's definitely not perfect. Find the center, you freak. Now I'm scared. I'm gonna do it. I don't even care. Here we go. It looks good so far. It doesn't look too bad. It's not terrible, okay? It's not terrible. Someone said, I don't know if it's the smart way to do it, but it's a way to do it. And you know what? I gotta agree with you. It is a way to do it. And I also agree that it's not a smart way to do it. Taking my feed pretty slow, like intentionally feeding it into the material pretty slow so that we shouldn't be like pushing it too much, because I recognize that like the work holding doesn't inspire a ton of confidence. Here's the thing, the work holding kind of requires that you really torque it down into the wood. Like, it requires biting into the wood. It's the Joe Barnard way. Sumark, I don't know if you know this too. I milled down 2 of the sides. I should have milled down all 4 sides so that we had a parallel on each side. But I milled down 2 of the sides. I know that doesn't guarantee orthogonality of the part, but I did mill down 2 of the sides, so that should have helped us a little bit with like tapping off of the sides. Gotta get those shots. There's a lot of chips in there. All right. Yeah, you should mill all sides if you're taking it off. I agree, Sumark. You're probably right. You are right. Is the Tormach 440 good? I quite like it, but I am not an expert machinist. I'm a hobbyist who has a mill that was granted to him early this year, so I would take the advice of other people over me. I like it as someone who has gone from 0 mills to this mill, or at least a desktop mill. Okay, this is square legs with a round hole. I could do this with a hand drill and some elbow grease. Yeah, I mean, it would be easy to do it in the lathe too. My lathe is pretty small, and I also kind of want to finish it on the machine for no good reason, really. Or find a bit of milled geometry to take offsets from. Yeah, sides don't matter unless you're grabbing offsets from them. You should never take offsets from raw stock unless it's for op 1. It can work, in this instance it seems to. It's just bad practice. Yeah. Going forward, maybe we better don't do that. Hans is also right. I mean, both of you are right. It would be better to do it a different way. And if this messes up, I'll never do it this way again. And if it doesn't mess up, I'll go okay, well, might as well try it again because it worked the first time. So I have this other piece of stock. We need to make 2 of these parts. So I have this piece of stock here that's got the top milled, the bottom milled, this side milled, and this side milled, and these are definitely not, right? That's from the saw. This is from the stock material. So if I mill these 2 down, that will help, and then maybe what we can do is for this version of this, when I make this tomorrow, I'll take the offsets from some internal geometry. The really tricky part of this is going to come when we get really close to the bottom of the part. I'm actually a little bit worried about that. We've got these big triangles that are hanging on up top. You can start to hear them chatter against the bit. Luckily the flute length isn't full length of the bit here. But this is not a thing I feel great about. I have a question. What engine do you recommend for a TVC rocket? I like the Estes F15. I quite like that. The Estes E9 is also great too. Both easy motors. There's the Apogee F10 or E6. Those are both good. Yeah, I'm happy I'm not crazy. I couldn't figure out how this centering method would work. Yeah. Would you even have attempted a part like this on the Nomad? I think the dimensions of the Nomad would have allowed this. However, the horsepower of the machine and the speed that basically yes, it could technically be done, It would also take an entire full day, if not more. Oh, Sumark says, I would have done multi-passes to make sure those triangles didn't exist. I thought about this. I thought about just adaptive clearing everything, and I was like, that's ridiculous. We don't need to clear material that we don't need to clear. Wish I did that. I'm gonna clear out some of these chips. We're getting there. Sketchy. Sketchy. The super glue and painter's tape methods works when you have a lot of surface area. And we sort of don't because we hollowed out a lot of the bottom. Maybe it does. I just can't imagine it has enough grip for a part like this. Okay, be right back. Keep an eye on it. Couple more passes. All right, we're getting into the danger zone, that is for sure. I do not feel amazing about this. After this, I think we have 2 more passes, so this is the 3rd to last pass. I don't have a good concept of how big everything really is. Trevor, if you have a ruler, so it is about, it's like 3.8 millimeters or something in diameter. So this is the size of Send It, this is the airframe diameter. This is the coupler diameter, right? They fit inside of each other, like that. And this part fits inside of the coupler. So this is like 3.75, 3.8, something like that, in terms of inches, and it goes inside there. This is a size reference. Okay, 2nd to last pass. The one after this will probably cut all the way through, but this might not. This might cause problems though. I got my hand on the stop button. I'm also slowing down the cutting. Okay, I'm doing a feed hold. It's a lot of rubbing here. This got very, very hot. So I think we should actually speed it up a little bit. Okay, actually one more. I'm gonna make sure this is tight. Yeah. Okay, I'm feed holding. This is the last pass. This is going to cut through. What's the procedure here? Should we just let it go? I shouldn't put my hand in there. I think that's a bad idea. I think it's not a good idea. Just let what happens happen, and then if it snaps something off, we can pause it and make sure it's okay. I think that's the best idea here. Okay. My tool is far out enough. We measured this. It is quite close, but it is far out enough. Got very hot. Oh, no. You're not doing more. That's it. Okay, not so bad. Pretty good. And when I say pretty good, I of course mean maybe. Let's not do that again. That is a lot of nasty stuff there. This does not look that bad. I mean, it looks like there's a bunch of crap all over it, but yeah, no, I think, you know, Sumark says he still hates it, and I get that. I think he hates it with good meaning, in fact, or with good reason. So here are the four corners. We definitely cut through the wood. Why don't we get the shop vac out? See how it came out. Oh, we can also get rid of some of this crud. Woof, it was not on there very tight by the end, I can tell you that much. It's also quite hot. A lot of rubbing of the tool going on. Okay. There. That's one. We have two washers. Kind of hard to get off. There's a bunch of oil in there. Oh my gosh. Okay, that goes there. But this is the part. You can sort of see the... Okay, thank you. can sort of see the idea behind it. Let me brush this off really quick. Okay, check it out. Got this side faces down, this side faces up. It actually eventually does get turned on the lathe. We put a bunch of threads in here to help engage the epoxy, and it gets epoxied inside. Oh, this is a really good fit too. Gets epoxied inside of this tube, just like that. Pretty nice fit. And that helps us transmit the load through this smaller diameter set of tubes. Oh my gosh, there's more adult dating sites. How are they finding my stream? More hot women in my area. Crazy. It's a hot tool summer. Anyway, this looks really cool. I'm stoked with how it came out. I don't think it's... I mean, in terms of like the final product, I'm quite happy. In terms of how we machined it, we took some shortcuts. We did some things that maybe I wouldn't recommend. It's also probably a heavier part than it needs to be. This is about 250 grams or something like that, and I bet we could get it down a little bit further, but I didn't want to do FEA, and this is the result. Yeah, really quite a nice finish there. And then on the side, there's some tool rubbing that resulted in some like what's basically all over my hands now. But this is all easily cleaned out. What I'll do is I'll take it out to the backyard, hose it down a ton with like a really high pressure sprayer, and that should get most of this stuff off. Anyway, yeah, someone's curious about the concentricity. We can find that out. So the wall here, if we want to do this, why don't we do it in millimeters? 0. Okay, so the wall here is supposed to be 2 millimeters, and it is 1.94. Opposite side, 2.06. So we are not concentric. As you might expect, it's not totally concentric. What was it? 2.06, 1.93. You know, it's like a few hundredths of a millimeter out. 2.04. This right here, 1.97. That's not right. 2.13, 2.00, 2.19, 1.99. Yeah, it's not totally concentric. This is well within the tolerance of what we need for this project. Awesome. Well, I gotta say thank you all for joining me. It's been a lovely little slice of heaven. I quite enjoyed it, and we ended up with a really fancy looking part. Good enough, I would say. I gotta make another one of these, and now I have a set of tool paths that I know work. Might, take centers a little bit differently next time. And, yeah, that's pretty much it. How am I gonna shut off this stream if my hands have all of this gunk on them? I have this nice laptop that needs a trackpad. Oh boy. All right, well, it's been a little slice of heaven. Thank you all for joining me. This was a long stream, 4 hours, 15 minutes, it looks like, at least on this end. It might be a little bit shorter on the YouTube end. Nope, 4 hours, 15. All right, well, it's been great, and we are still on track to fly Send It at Rockstock, and we're still on track to do Meet Rocket this year. So I'll talk to you all soon. We're gonna machine another one of these. I probably won't stream it, but there's plenty more machining stuff coming. All right, sounds good. Have a good night. Bye.